Okay, this is the video for homework 2, problem 4, and 3360. So problem 4 asks you to calculate the energy stored in the magnetic field for x equal to 0.005 meter, right? So let's try to do that. So, some reluctance of the 0.005 is equal to 7 times 10 to the 8th 0.007, right? So that is the 9.5 times 10 to the 6 1 over Henry, right? So the energy stored the magnetic field is equal to 1 of half inductance I squared, right? So inductance is n squared over our reluctance at 0.005. That is equal to 980 squared over 4.9 times 10 to the 6, right? So that should be 0.196 Henry. So our energy equation is the 1 of half 0.196. And what is the current? So current is the voltage over resistance. So that is we apply to 120 volts per 3 ohms, right? So we apply 4 ampere. So here we apply 4 ampere. So that is the 1.568 joule here. That is the answer for A. And B. The magnetic force F is equal to minus 1 over 2 P squared d Rx over dx, right? So we know our flux is the Ni over reluctance 0.005 at 0.005. The number of turns is the 980 turns, right? And we have 4 ampere over, we have the 4.9 times 10 to the 6. So that is 8 times 10 to the minus 4 Weber. And derivative of the Rx is equal to 7 times 10 to the 8, right? Therefore, the force is equal to minus 1 over 2, 8 times 10 to the minus 4 squared, 7 times 10 to the 8. So that is minus 224 Newton. So what is the negative sign means here? The minus sign indicates the first F is in a direction opposite to that indicated in the figure. So this is the answer for B. Okay, let's move on. So here, if we are given that the cross-section of the structural elements is a square, yeah, and we have to get the length of the mean path, right? And the cross-section dimension of the core, right? So our reluctance expression is the 7 times 10 to the 8, right? 0.002 plus 7 times 10 to the 8x, right? So we know about another expression of the reluctance, right? Air that core over mu 0 a plus 2 over lg mu 0 a, right? So here this lg should be x. So this term is the constant. This term is constant here, right? And also this term should be matched together. So here we assume that the area of the air gap same with area of the core. So we just ignore the fringing. So we can just use the same area of here. So that means 7 times 10 to the 8x equal to 2x over mu 0a, right? So here x is the cancel out. A equal to 2 over 4 pi times 10 to the minus 7 and 7 times 10 to the 8 is the 0.00227 meter square. So this is the area cross-section dimensions of the core, and also we have the 7 times the 10 to the 8.002 equal to air core over mu 0 a. So L core is equal to 7 times 10 to the 8 times 0.002, right? The mu is the 1000 and mu 0 is the 4 pi times 10 to the minus 7, right? And A is the we know here. So 0.00227 is equal to 3.99 meter. So this is length of the mean path of core. Okay, let's move on. So draw the current I in the coil as a function of time. So at the coil, the electrical circuit looks like that. Looks like we have the resistance here, right? And we have coil here, right? We have coil here. We have the plus minus the voltage here, right? We have the R resistance and the inductance here. So this is this one to apply the voltage. So this is the mentioned from the problem 4 explanation. So this resistance is the 30 ohms, right? So this inductance is this coil right? So inductance is the n square of the r, but this is the function of the x. X is fixed at 0.005. So there's a 0.005. That means we know about that 980 square over 4.9 times 10 to the 6 watt Henry, right? So that is the 0.196 Henry. Got it? From the Kirchhoff voltage law, so the equation of this the electrical circuit is the voltage minus Ri, because there is the voltage drop here, right? This is applied the input voltage. So for the resistance, so what is voltage? Voltage is the Ri, right? Resistance R times current, right? So what is the voltage for that inductance? Inductance times di over dt, right? So this is a di over dt equal to 0. So that means we plug the numbers here. So we apply 120 voltage, right? And 30 the ohms I minus that is the 0.196 dt di over dt is equal to 0. So I organize this equation 0.196 over 30 di over dt plus I equal to 120 over 30. So from here, the tau, because this is the first order ODE, right? Or ordinary differential equation. So our time constant tau is equal to what? Point equal to this one, right? 196 over 30. This is equal to 6.53 millisecond, right? So I draw this is the x-axis is time, this is current. So there is some step input, the current at t is equal to 0, right? So this is the step function, the step input, this is 4 ampere, right? And our system response is looks like that because this is the first order ordinary differential equation. So our time constant t, this is 0. Time constant t is the 6.53 millisecond, right? This is the point what? 0.630.2% at tau, right? So this should be 2.53 ampere at this point. So this is answer for problem 4. Thank you.